Hello guys, welcome to all of you. Let us see a question on MOSFET. In this question, it is said for the MOSFET shown in the figure, the threshold voltage mod of VTH is equal to 2 volt and K parameter is given as mu upon 2 CH W by L is equal to 0.1 milliampere per volt square. The value of ID in milliampere is. Let us see how can we solve this question. So this is the circuit given to us. First of all, let us see the region of operation of these two transistors. To find out the region of operation, if we see, then for transistor M1, VSG1 voltage, that is the source to gate voltage of this transistor, is equal to 12 minus 6. This is 12 volt, source volt is 12 volt and gate voltage is minus 6 volt. That is equal to 6 volt. So we can say that VSG is greater than mod of VTS. Mod of VTS is given in the question and its value is 2 volt. Since VSG is greater than mod of VTS, then we can say that this transistor may be in saturation region or in linear region. Similarly, for M2, VGS2, this is the gate to source voltage of this transistor M2 will be equal to 0 minus 5 volt. Then this will be equal to 5 volt. Since VTH is 2 volt, so VGS2 is greater than VTH. From this, we can interpret that VGS2 is greater than VTH. Then this transistor M2 may also in sat region or linear region. So we will get an assumption that both transistors are working in saturation region, and after calculation we will analyze whether our assumption was right or not. So here IDS1 current, that is the saturation current in P MOSFET, can be written as Kp by 2 G minus mod of Vt2 whole square. Put the value of Kp by 2, that is given as 0.1 in the question, and VSG voltage is 6 volt and mod of Vt is 2 volt. We calculate, then its value will be 1.6 milliampere. So at this value of drain current, our transistor M1 will enter into saturation region. If we see this IDS2 current, by assuming that M2 is working in saturation region and putting the values given in the question, that is Kn by 2 is equal to 0.1, VGS we have calculated 5 volt minus Vt is equal to 2, then its value will be equal to 0.9 milliampere. As we can see that both transistor in cascade form, so the same current will flow between these two transistors. This IDS current will be equal to this IDS current. Since 0.9 milliampere is maximum current which can flow when M2 is in saturation region. Maximum 0.9 milliampere current can flow in these cascaded transistors. ID current, which is the current flowing through these two transistors, will be minimum of ID1 and ID2. So 0.9 milliampere is minimum between these two, so it will be equal to 0.9 milliampere. If ID current is 0.9 milliampere flowing in this circuit, then we can say that this transistor M2 will be in saturation region, since its saturation current is 0.9 milliampere, but 1.6 milliampere current required to go to this M1 transistor in saturation region. 0.9 milliampere current flowing through this M1, so this M1 will not go into saturation region, it will remains in linear region. Saturation current value of ID is this, and we have less amount of current flowing this transistor, then our transistor will work in linear region. So transistor M1 will work in linear region. We can say from this interpretation that our M1 transistor will work in linear region and M2 transistor will work in saturation region. Let us see other method to find out the region of operation. We calculate the overdrive voltage of transistor M1 and M2. So we can see that transistor M1 is P MOSFET. So overdrive voltage for M1 will be equal to VSG1 minus Vt. That will be equal to 12 minus 6 minus 2 is equal to 4 volt. For transistor M2, the overdrive voltage will be equal to VGS2 minus Vt. That will be equal to 0 minus 5 minus Vt equal to 2. It will be equal to 3 volt. Since overdrive voltage of transistor M1, that is equal to 4 volt, is greater than overdrive voltage of transistor M2, that is equal to 3 volt. So we can say that M1 is in linear region and M2 is in saturation region. Overdrive voltage of which transistor have greater value will be in linear region and the other transistor will be in saturation region. In this way, we can also find out the region of operation of both these transistors. So ID is equal to 0.9 milliampere is the answer of this question. See you guys in next video.